Hello everyone, welcome to my channel. Today we are here to discuss a short trick from the chapter Logarithm. So, we have to use this trick in questions in which we have been asked to find a number of positive integers having some characteristic x and the base of the log is given suppose y. So, the trick is that the number of positive integers required equals y to the power x into y minus 1. So our first example we take, find the number of positive integers which have the characteristic 2 if the base of the log is 7. So the required number of positive integers is 7 to the power 2 into 7 minus 1, which is 49 into 6, which is 294. And this can be easily proved as 342 is the last positive integer having the characteristic 2, as from 343 we have the characteristic as 3, and 49 is the least number having the characteristic 2, because if we go before that then the characteristic of the log becomes 1, and so we have to subtract the positive integers before 49, which is 48 from 342, and when we do that we get the same answer as 294. Now we take a second example. So the question is, find the number of positive integers which have the characteristic 3 if the base of the log is 5. So the required number of positive integers equals 5 cube into 5 minus 1, which is equal to 125 into 4, which is 500. And this can again easily be proved as 624 is the last positive integer having the characteristic as 3, because from 625 onwards we have the characteristic as 4. So, and 125 is the least number having characteristics 3. So, we have to subtract the numbers which have characteristics less than 3 from 624, which is 624 minus 124, which also gives us 500. And now we take the last example, and the question is, find the number of positive integers which have the characteristic 3 if the base of the log is 8. So the required number of positive integers equals 8 cube into 8 minus 1, which is 512 into 7, which is 3584. And again this can be easily proved as 4095 is the last positive integer having the characteristic 3 with base 8, as from 4096 onwards we have the characteristic as 4. And similarly, if we look at the least number, so we find that the least number is 512. So we have to subtract 511 from 4095, and so the answer we get is 3584. So now let us look at the proof of this trick. So the largest positive integer having characteristic x and the base of the log y equals y to the power x plus 1 minus 1. And the reason is, since two successive integers have a difference of 1, and from y to the power x plus 1 onwards the characteristic of the log becomes x plus 1. So if we subtract 1 from it, then the characteristic of it will be x, and that is the largest positive integer having the characteristic as x. Similarly, the smallest positive integer having characteristic x and the base of the log as y is equals y to the power x. Number of positive integers lying before y to the power x equals y to the power x minus 1. Suppose suppose the answer of this is 49. Then the number of positive integers lying before 49 is 48, since 1 is the first positive integer. So we have to subtract. So the required number of positive integers now equals y to the power x plus 1 minus 1 minus y to the power x minus 1. This minus this. So when you open the brackets, this becomes plus 1 and gets cancelled off. So we are left with y to the power x plus 1 minus y to the power x. Now we take y to the power x common, and we have y to the power x into y minus 1. So hence we have proved this trick. Thank you everyone. Follow for more.